an argument apparently about cabbages. Oh, that's what she told me, that you said let us go cabbages, and the other argument about cabbages.
Okay. Now, are there any ones left for dependent or independent variable? Remember, the math usually happens to the IV. So, y equals 2x plus 7. The math is happening to the x. The math is changing the x, which results in a new y. So y depends on what happens to x. Yeah? Okay. I don't like using red. I can identify a relation as a function. Remember, there's two ways to do this. How do you do it on a graph? But if it's on a graph, how do you do it? Thanks, Jordan. The vertical line test. How do you do it if it's not on a graph? Right. Each IV can only have one dV. Notice I'm not using x and y, because we're not always using x and y, right? If a relation is linear, how is it linear? Again, if it's on a graph. It's a straight line, not straight up, it's a straight line. So, if this is always constant, if that x, and that x are all the same, and that y, and that y are all the same, then it's a linear equation. If it's in a table, x, y, 3, 5, 7, 8, 12, 16. Up by 2, up by 4, up by 2, up by 4. Linear. Discrete and continuous data. Is everybody okay with that? This one gets a little tricky. Who remembers the little thing I explained to? Discrete data is what? Discrete data is? Pardon me, Prab? Is that Joe?
Discrete data is the dots.
Yes, that's how it's shown on a graph. But how do you know if you're going to put the dots? Yeah. Discrete data is counted. How many cups are on my desk? Right? Is there any number of cups on the desk between 1 and 2? No. So this is discrete. Is the distance between the cups discrete or continuous? Continuous. Because you could say it's a foot, you could say it's 12 inches, and you'd shorten it down. So everybody's good with discrete and continuous? Okay, now here I just want to take a second just to show you something. This is time between classes. Everyone agree? How much time do you have between classes? 5 minutes, right?
Yeah.
So 1, 2, 3, 4, 5. Yes? This is kids in the hall. At 0 time, it's Abby Senior. So how many kids are in the hall? Quite a few, right? Because it's Abby Senior. How many kids should be in the hall at 0 time? 0, because they should all be in class, yes? All right. So let's pretend this is how it should be. The bell rings. Everyone leaves within the first minute. Every kid in the school is out of the class. Yeah? Okay. So every kid in the school, let's say there's 1,000. So from 0 to 1,000, I go up to there, yes? What starts happening from 1 minute now? Starts going down, because if your class is next door, you're out of the hall, yes? So it's going to go down a little. What's going to happen between 4 and 5? That's going to be the biggest drop, right? Everyone agree? Is this discrete or continuous data? Really? How many kids are in the school? Is it if it's discrete, then why have I drawn a line? Because didn't you guys just tell me discrete needs to be dots? You can't have half a kid. So wouldn't this have to be discrete? Yes. But if I actually had to do this discrete, how many dots would I need between here and 1,000? I'd need 1,000 dots, wouldn't I? I'd have to count each kid. If I actually put 1,000 dots there, what am I going to end up with? A line. Does everybody understand? Even if it appears continuous, because you've used a straight line, you have to actually know what the definitions mean. Right? Because there can never be half a kid in the hall, can there? All of these numbers have to be one number. But I would have to make the graph from here to Prab to the back of the room if I wanted to put a dot for each kid, right? And I'd have to count every single kid in the building. I'd have to run around 1, 2, 3, 4, 5. It would be impossible, yes? So sometimes, even when the data is discrete, it appears continuous. Everybody with me? Sweet. So that's the little bit of a trick there. That's why I don't like using the definition of if it's dots or a line. Because sometimes, what is a line? It's just a million dots really close together, right? Okay. Can we do domain and range?
Can you just go over the definition
Of which?
of discrete? Like what?
Discrete is counted. Continuous is measured. And a good way to remember is if you can have fractions, it's continuous. All right. Domain and range. Can we all find domain and range?
Can you give a definition for
Domain is the set of IV. So that example I drew over here, there's 5 minutes between classes, right? So the domain is 0 to 5. Because that's the independent variable. Now, is it 0 less than or equal to time less than or equal to 5? Or is it 0, 1, 2, 3, 4, 5? Which is it? Top one. Why, Tashir? Can I have fractions here? Can I check how many kids are in the hall at 30 seconds? Time doesn't stop. And I can check, can't I? Okay, good. What's the range? That is the set of dv. Now, over here in this example, we're in a bit of trouble, aren't we? Because the kids in the school goes from 0, in the hall goes from 0 to 1,000, yes? But if we were to list it, technically, since it's discrete, I would need to do 0, 1, 2, 3. How many times? 1,000 times. That's stupid, isn't it? So for the domain or the range here, we would still use 0 less than or equal to kids, less than or equal to 1,000, but we would add that kids are a set of whole numbers. 1, 2, 3, 4, 5, 6. Everybody understand? This part is not important to me in grade 10, but it does become important in grade 11 because you can't have half a kid. Right? There would never be 882.5 kids in the hallway, would there? Right?
Unless he's like half in the world.
Then he's still in the hallway. Right? If your foot's in the hallway, you're in the hallway. Just like if your foot is touching the line in a sport, you're out. All right. Everyone good with domain and range? Okay. Can everybody tell me a story about a graph? Like the bicycle question. You did it, you just did it on your review. Time, distance. I walked away from home. I forgot my wallet. I walked back towards home. Then I walked to school. Everyone can do that? All right. Can everybody do it in reverse? If I give you a story, can you make me a graph? I stood up, I went to the bathroom, I came back to my seat. I stood up, no distance has passed, I walked to the bathroom, I walked away, I came back to my seat. Done. Now, on my way to the bathroom, on my way back, I stopped and talked to Mr. DeVries. On my way back, what happens right there when I stop and talk to him? Time goes along flat. Why, Jordan? Time doesn't stop. Did I get any closer to my desk? No, because I was talking to DeVries. Then I came back to my desk. Everyone can do that? And lastly, function notation. Can you all do this with algebra? That's numbers. So if I tell you the f of 2, what is it? 3 times 2, which equals 6. What if I tell you the f of x equals 9? Where does that 9 go? It replaces all of that. So 9 would equal 3x. Divide by 3 and x would equal 3. Everybody can do that? On a graph, there is a point. 3, what would be the y value with this function? If x is 3, f of 3, what would be the y value? 9. Right? And how would you do that? There'd be a line there. You'd go to 3, you'd check. Oh, and this would be 9. Everybody good? When is this test?
Monday or Tuesday.
Most likely Tuesday, right? I'm not too keen on Monday test. Chairs up, please. There's a lot of people not here. It would be very helpful if everybody would put up one extra chair. What? Quizzes are yours to study from. You can throw it out. I don't want it. I marked it. Well, I recorded it.